Hello everyone, and thank you for joining in for the session. So this is on Generation Z of the energy sector, and obviously that is energy storage in many ways. So today we are going to discuss on this in detail, and thank you for joining in for the session. Now if I see the Indian power sector status quo starting with this amount of installed megawatts today, we are at 366 gigawatts of installed capacity. Now all these figures we all know. What I want you all to focus on are two numbers here. One is the daily peaks that are getting and the grid reserve margin. The daily peaks are in the range of 150 to 170 gigawatts, whereas the grid reserve margin has been increasing quite significantly over time. Of course, one of the reasons for this has been the increase in the amount of renewables in the grid. Now, if I see the Indian grid as a whole today, what we see is that coal percentage in the grid is around 54%. Renewables today stands at around 24%. But what has happened over time, if we see? If you see the percentage of coal that was in the grid in 2010 and that as it is today, there's not much difference between that. What has actually increased is the renewable percentage from 10 to 23% or 24% today. What has decreased is the amount of diesel in the grid, the amount of gas in the grid, right? And also to a great extent, the growth of coal has been stagnant. Let's see. What has been the growth like of various fuel types over time? If you see the black line, that is of diesel. So very clearly diesel has gone down, right? What has also gone down, if you see the brown line, is coal, right? It has gone down quite a bit over time. So the growth has gone down. Installations did happen every year, but the growth at which it was growing came down. What rose up is the renewables. If you see 2017, it was around 37%, the growth. It was huge, right? Now, therefore, we see that the renewables grew quite a lot over this decade. Now, let's get into renewables. Let us talk about its capacity and also talk about the tariffs. If you see from the starting at 2010 to 2019, wind grew, right? But what grew actually remarkably is solar. It is almost at par with wind today in terms of tariff and in terms of capacity. It tells you a lot what is going to happen coming forward, right? So has the tariff gone down. Now, this is what we see as a RE dashboard as on today. Capacity of 86, out of which wind is 37.7 as on date and solar is around 34.5. Now, but if you see the spread of wind and solar, it also tells you a story. While wind predominantly is spread across pockets, solar has a much broader spread across India, right? The other two are, of course, small hydro, which is around 4.7 gigs, and biofuel or biopower, which is around 10 gigs. What are the long-term projections? If I'm talking of 2030, we are looking forward towards a grid whose capacity will be around 479 gigawatts. In terms of energy, it will be around 1,700 terawatts hour, right? And coal, if you see, has actually gone down to 45, whereas renewables has increased to around 37%. Remember, we are talking this as a grid which has around 450 gigawatts of installed RE capacity as per the government targets. Now, amongst all these, which a number also what I want you all to focus on is the grid level storage requirement by 2030, which is around 34 gigawatts or 136 gigawatt hour. Also, the peak demand has been increasing quite significantly over time. So, RE till now had quite a nice journey, but going forward, today, if I talk about the 2022 targets of 175 gigawatts of renewables, out of which 100 will be solar and 60 will be wind. How much we are in wind? We are 37. We need to reach 60 by 2022. We are halfway right? But in solar, there is a lot which needs to be covered. What are the challenges today? High curtailments. With the increase in renewables, what was not increased concurrently was the evacuation capacity, due to which today we see high curtailments in certain states. Now, renewables increasing in the grid, so what was also understood was we have to promote renewables, so it was given a must-run status. But then, on heavy penetration, what was also required was to make renewables responsible. Therefore, strict DSM rules were taken in. Offtake risks has been there. We have seen that. Land availability. Now, the potential of wind is around 302 gigawatts in India, out of which a study says that much of this potential is actually coming from agricultural or forest land. That means it's difficult to actually acquire those lands or approach those land parcels, right? So there is a trouble there. Increasing grid variability has been a concern, and lower tariffs. So what I want to tell is that alone wind or alone solar going forward, the challenges will be more. We need certain things by which we can actually club these two together. What is the opportunity therefore? The complementary nature of these two resources, wind and solar. If I'm talking of wind and solar, let us talk of a monthly variation. You see, what happens is when wind is high, solar is low. When solar is low, when solar is high, wind is low. That is, they complement each other. And this is not only on a monthly basis, this is also on a daily basis. Depending upon a high wind month and a low wind month, or a high wind day and a low wind day, each of these times, they complement each other. So, if we can combine these two, then the variability that we are talking about today can reduce to a lot extent. Now, when we are talking of so much renewables, then what is happening in the grid? What is happening is the load curve is slowly changing. In order to accommodate this high renewables in the grid, what is decreasing, what has to go down is the other fuels, right? So what this also means is during the evening hours, when solar actually plummets down, you also need to ramp up those fuels which you ramped down during the day. Therefore, the ramp up percentage increases, and we see that in a high RE grid, this ramping up percentage can increase to around 135% of what it is today by 2030. Now, let's come to a real example. 26 December 2019, there was an annular solar eclipse. Practical example. With today's solar and wind potential, we have faced a ramping up of 123 megawatts per minute, and that lasted for 1.5 hours. This was in the morning hours. Now think, with only 34 gigs or 72 gigs of renewables, this is the condition. What will happen when this reaches 450 gigs? One more example, 25th of the last month, when with 2 days, one was the Janta curfew day and the other was 9 minutes, when all the lights were told to be switched off by our Honorable Prime Minister. So you see, the ramping is increasing a lot. That means we need a buffer. And that buffer, one way of that buffer is storage of this energy. So therefore, why we need storage comes from these all ingredients. Curtailments has been seen increasing, deviation settlement mechanism penalties are increasing, regulations are increasing, EVs are coming into the grid variability is increasing, and to cater to this renewables, the coal plants or the conventional units are being brought down, therefore the inertia in the grid is going down. Therefore you need a buffer which will take care of the variabilities present. Now, when we talk of storage, it's often seen that people tend to focus on storage predominantly as batteries or lithium ion. Why? Because it is more seen today. But it's much more than that. If you see the technology spread, it can be mechanical, chemical, electrochemical, electromagnetic, thermal, so many types. Today, we will be predominantly talking of battery storage. Now, let us go through some key metrics while we are talking of this. One is energy density. What does energy density mean? It means the compactness of the technology. It is the total energy divided by the weight. How much energy are you able to store in how much space? The more energy you are able to store in less space, your energy density is more, and it makes it much more beneficial. Similarly, we have cycle life. Cycle life means a test measures the number of cycles that will be performed, charge discharge, right? Before it decreases to 80% of its initial capacity. Efficiency is quite simple. Self-discharge is the total recoverable idling loss that occurs during the time of no usage of this battery. Calendar life, of course, means how much life the cell or the battery has. And DOD is depth of discharge. How much are you discharging in the battery? Why I told you these? Because we will be talking about these as we go forward. Now we need to understand here one thing. Energy density and power density. What did I tell you about energy density? It's the amount of energy you can store in the how much amount of space. The power density is how much energy can you discharge in how much less amount of time. That means power density is more required when you're dealing with grid situations, low frequency management, all these things. There you actually need to discharge a lot in a much less amount of time. But if I'm driving an electric vehicle, which is more important for me, power density or energy density? Of course, it's energy density. Now, depending upon this, depending upon the size and discharge time, we can actually, spread out all these technologies. Now, why are we talking today about lithium ion? Because it has a much broader spread, right? And it's also more commercializable as on date. Even lithium ion, you have various technologies. You have LCO, LMO, LFP, NMC, NCA. Depending upon the application where you need the batteries for, you need to choose this. Someone is good in power density, someone is good in energy density, someone is good in high temperature tolerance. So, there are some matrix on which you need to choose your battery. Is it a power or energy application? What is the cost? How much discharge do you need? What is the efficiency you need? What is the charge and discharge duration you need? And obviously, what is the environmental impact of it? Right? Cool. And these are the projections going forward. What do we see of all these technologies that we were talking about? Nickel, cobalt, aluminium, lithium titanate, nickel, manganese, cobalt, all these. What are the projections going forward in terms of densities? All of them are increasing, but how much is that increase? That is the question. Obviously, the other point is cost, which has decreased almost around 85% when we consider the cost from 2011 to date. And these costs will further go down. Will the curve be so steep? Definitely not. It will not be so steep as it has been till now. And what are the demands? Where are the demands coming from? Global demands, automobile sector, 60%. energy storage, portable electronics. So these are all the main demand centers for which the growth has been such phenomenal. In Indian context, if I'm talking about, there are two kinds of application, mobile as well as stationary. Mobile, you have personal vehicles, you have commercial vehicles, you have electric buses in which they are coming, and it also shows you the propensity, which is low hanging fruit, which is in medium scale, and which is in long term. Obviously, the same happens on stationary applications. What are the areas? Diesel replacement, microgrids, renewable integration, T&D upgrade. So these are the various applications in stationary side. What is the market like? If we see the total market, our analysis says that by 2026, it can be more than 300 gigs. This, of course, the main pie of here is the red one, which is electric vehicles. Apart from that, you also have the others. If you see the top 5, railways, RE integration, UPS, telecom, and inverters are the top 5. Let us talk of utility scale here. We will be discussing mainly on the utility part. So where are the operations? Where are the applications? System operations side, you have frequency regulation, flexible ramping, black start operations, investment deferral. You have T&D relief, congestion relief. You have energy shifting. RE integration side, you have reduced RE curtailment, as well as you have capacity firming. And microgrids, how can you optimize DGs as on date and sustainability of off-grid and grid-connected microgrids. Now, based upon the application, what is the most suited duration of storage? This chart actually tells you what is the optimum duration of storage in what kind of applications. It can be as low as 0.25 for frequency regulation, and it can go up to 4 hours for replacement of bigger plants. So overall, if we see, what are the application areas? We talked it before also, let's talk it once more. Peak power management, energy shifting, frequency regulation, voltage support, curtailment mitigation, ramping reserve. Now understand one thing here. Storage, if you are applying it with RE, it cannot be applied for just single application. If you want, okay, I want to manage curtailment through storage for RE, it won't work. Financially, it won't work. Why? Because of the cost dynamics. But that storage, when deployed with RE to target multiple applications, it works well. That's what we are seeing today. And it's possible. Now, what is the battery storage market like with RE? Only India. If we are seeing from 2020 to 2027, so if you see the blue line, that is the minimal and the maximum potential over years. Also, how much duration of battery storage will be there? So it can be minimal of 1 hour to start with to a maximum of 6 hours by 2026-27. That's what we see. Now, let's come to the cost part therefore. What does the cost part look like? Of the total storage at system level, what are the breakups like? Only BESS, that the battery with the BMS, battery management system, is around 65%, followed by the balance of system cost, that is around 7%, container around 10%, PCS and EMS around 16% of the cost, project management very low, and then O&M, which is around 1%. This is the typical breakup of a storage project cost. What are the costs therefore like? Today, a 1 megawatt or 1 megawatt hour standalone solution, only storage, costs around $342 per kilowatt hour. If I move that from 1 hour to 4 hour, you see there is a drop in costs. It comes down from 342 to 243. Huge drop. Now, when you make this not a standalone but with renewables, what happens? It further reduces to $226 per kilowatt hour. Why is this happening? Why this drop? This is because when you co-locate a storage project with renewables, you share a lot of the BOS costs. Therefore, proportionately, the total investment decreases a lot. Also, when you increase the number of hours, what happens is the cost gets proportioned. Therefore, the overall cost reduces a lot. Now, when we compare the BOS, as I was telling you, actually shared the cost. So, how do you relate between a BOS of a battery storage system with that of a solar PV? So, here you see how many similarities: the transformers, the inverters, the protection controls, the controls and communication. All these costs can be shared between the two projects. So, as I was telling you at the beginning also, standalone solar or standalone wind, going forward, it will be difficult. So the solution is hybrids. Now, you may ask me a question, but hybrids, India has passed a hybrid policy, there were tenders, but did we see a lot of interest from the industry? No, it was not there. Some of the reasons were like the ceiling tariff, which was imposed on it. And specifically, this was a very new thing which came to the market. At initial, there will be hindrances, but then what we understand now with the ceiling tariff gone and with battery prices coming down, the interest will grow over time. Just talking about tenders with renewables over time, has there been tenders? There has been many tenders which has been released. What are the durations like? Some of the initial ones got cancelled, but now we see much more tenders coming out, much more interest coming out, the latest being the SECI bid of 1.2 gigawatts, which Renew and Greenco won. So overall, the projections look positive. Let's talk about the 1.2 gigawatt wind solar hybrid project. It was a 1.2 gigawatts total capacity, out of which 600 megawatt hours for 6 hours was storage, which had a different tariff. Now Renew won 300 megawatts, therefore its storage was 150 megawatt hour for 6 hours, and Greenco won 900, so 450 megawatt hour for 6 hours. Now if we talk about only the storage part, battery storage, the blended tariff was around 4.3 as we saw. This, if we consider 4.3, considering it will be commissioned in 2022, and take it down based on the reduction of overall cost, by 2027, the blended cost can be as low as 2.8. That is what we are talking about. Almost, racing with the standalone solar or wind costs. Also being very competitive with new coal plants. What is the blended cost trend like, therefore? We are talking of 1 hour storage versus 4 hour storage. Obviously, with 4 hour storage, the cost as on today will be more because you're using more energy. Obviously, the costs are not that low. So today we are talking of around 5.3 rupees in the best case scenario. Now this one can go down to around 3.38 in terms of 4 hour storage. In terms of 1 hour, it can be going down to as low as 2.77. That is what we are talking about today. So overall, what I'm trying to say is it's no longer not viable. It's very much viable. In fact, SECI is coming out with a similar model of 1.2 gigawatts with a peaking tariff coming in the coming days. So this will be the normal going forward. So be prepared for it. And also it's viable. It's no longer non-viable. We have many players in this space, technology players and suppliers. This slide shows you a snapshot of the same. So what's next for storage? What's coming up? Where are we in the growth curve? For storage, we are still in the initial growth phase. Nothing has happened. We are just at the start of a roller coaster ride. Lithium ion is just one small part. There are so much developments happening, so much research happening of long duration storage, grid scale storage, making it mainstream. We are talking of metal layer batteries, solid state batteries, fuel cells, supercapacitors. so many various varieties. We will see cost going down and the values actually increasing. From initial 2 to 3 value propositions, it is increasing a lot over time. So that is what makes it much more beneficial. So yes, that's what I'm saying, that renewables, if you see in a project cycle of renewables, they are in its early maturity or maturity phase. That means the growth will not be that steep going forward. But to maintain that growth, therefore you need an inflection. And that inflection is hybrids. And to make hybrids sustainable, we have to have storage included in that hybrid. That will make the value proposition much more interesting going forward.